Assalamualaikum and welcome to the channel Mathematics Videos. Today we are going to solve question number 21 through question number 30 of the exercise 2.2 of the text calculus and analytic geometry by S.M. Yusuf. We will start straight away from question number 21. Question number 21 is f of x is equal to x square times square root 2 times a times x minus x square. And from question number 21 to question number 32 you have to find out the derivative of f of x, that is f prime of x. So we will differentiate both of the sides with respect to x. We get f prime of x is equal to, we should make use of the product rule of the derivatives, and we will get the derivative of the first quantity, that is x square, and its derivative is 2x times second quantity, and it is 2ax minus x square, and then plus first quantity has to be written as itself, and we have to take the derivative of the second function. And the derivative of the second function is, you have to simply apply the rule of the power rule of the derivatives. 2ax minus x square multiplied by the derivative of the base, and it is 2ax minus x square. The base is 2ax minus x square, and its derivative is 2a minus 2x. Next you have to simplify it further. It is 2x square root 2a minus 2ax minus x square plus 2 has to be taken common, and it cancels out with this 2, and we simply get x square times a minus x divided by square root 2ax minus x square. You have to further simplify it out, and it takes the form as I'm doing. 2x times square root 2ax minus x square whole square plus ax square minus x cube. This square simply cancels with square root, and we get for ax square minus 2x cube plus ax square minus x cube divided by square root 2ax minus x square. You have to collect the like terms, and you may get 5ax square, and 2x cube minus x cube become minus 3x cube. All is divided by square root of 2ax minus x square, and it is the answer of f prime of x. Let me confirm it from your textbook. 5ax square minus 3x cube divided by square root 2ax minus x square. Yep, it is the answer. We will move to the next question, and this question is also quite a very simple question. F of x is equal to natural log of e raised to the power x, and whole is divided by 1 plus e raised to the power x. Before differentiating, we have to apply the rule of derivatives, the rule of logarithms, and by applying that rule, the division sign is converted into negative, and natural log is divided between numerator and denominator. It is distributed between numerator and denominator, and the division sign is replaced by negative sign. And again, we may use the rule of powers of the logarithms. The power simply comes at the start of the log, in the second quantity the second function has to be written as itself. As it was discussed in one of the previous videos that ln e is equal to 1, therefore x multiply 1, which needs not to be written with x because 1 is the multiplicative identity of real numbers, minus ln times 1 plus e raised to the power x. So it is your simple form of your given function. Next you have to differentiate it, and by differentiating both of the sides with respect to x, you get the derivative of x, that is 1, minus derivative of ln 1 plus e raised to the power, it is simply 1 divided by 1 plus e raised to the power x, and multiplied by the derivative of 1 plus e raised to the power x. Here we have just used the definition of the derivative of logarithmic functions, and especially the definition of the derivative of natural logarithmic functions. So minus 1 divided by 1 plus x, 1 plus e raised to the power x. Next, the derivative of 1 is 0, which has not to be written here, and the derivative of e raised to the power x is the same, e raised to the power x. You must be familiar to the derivatives of natural logarithms and logarithms and exponential functions in order to solve such questions. Next, you have to simplify it, and you would get 1 multiplied by 1 plus e raised to the power x minus 1 multiplied by e raised to the power x. So 1 plus e raised to the power x minus e raised to the power x, and whole is divided by 1 plus e raised to the power x, and it comes out to be equal to 1 divided by 1 plus e raised to the power x, since e raised to the power x and negative e raised to the power x cancel each other, and this is the answer of your question. Yup, it is. We will solve out the next question. This is quite very simple. and it is question number 23, and it is f of x is equal to x raised to the power natural log of x. We already know that how to deal with such question. We have to take the natural log on the both of the sides, next we have to apply the rule of the natural logs, power rule of the natural logs, or simply the power rule of the logarithms. The power has to be written at the start of the natural log and the rest remains same with the power just removed. Next, you have to differentiate both of the sides. Before differentiating, you may notice that this function and this function, both of these functions are same, therefore we can recombine them to write ln x whole square. Note that this square cannot be written in the start of the natural log because this square serves as the square of the whole of this function. So therefore, if you would like to write this as 2ln x, then it would be a huge mistake. Next, you have to differentiate both of the sides with respect to x, and you have to apply the corresponding rules. Firstly, on the left hand side, you have to apply the rules of derivatives of the natural logs, and it is simply this. And here you may have to use the power rule of the derivatives, and it is 2 times ln x and the derivative of ln x. Next, write the left hand side as it is, and just simplify the right hand side. Left hand side has to be written as it is, and you have to take the derivative of of ln x here at the right hand side. So you get f dash of x is equal to, just shift this f of x right here, you might get f of x multiplied by 2 times ln x whole divided by x. Simply replace f of x by its value, and its value is f of x equal to x ln x. It is given in your question. X raised to the power ln x times 2 ln x divided by x. Further, you can simplify it because here is the base x and here it is also x, so you can combine it by using the rules of powers of the fractions. So you get x raised to the power ln x minus 1, and whole is multiplied by 2 ln x, and it serves as the answer of your question. It can also be written as 2 x raised to the power ln x minus 1 multiplied by ln x. This is the final answer of your question. Next, you have to solve question number 24. It is also quite easy question. So problem number 24 is f of x is equal to natural logarithm of 1 plus square root x and whole is divided by 1 minus square root x. Before taking the derivative on the both sides with respect to x, you have to just simplify this function by making the use of rules of natural logarithms, or simply the rules of logarithms that you have studied in the 9th grade. 1 plus square root x, division is again converted into negative, and the natural log has to be distributed over numerator and denominator. Now this function has been simplified, and you can take the derivative of this function. And by taking the derivative of this function, you have to use to take the derivative of this function, you have to simply apply the rule of natural logarithms, the rule of the derivatives of the natural logarithms. So it comes out to be equal to 1 divided by 1 plus square root x times the derivative of 1 plus square root x. This is actually the definition of derivative of natural logarithms, and then same has to be done here, and you might get 1 minus square root x times the derivative of 1 minus square root x. We can further simplify it. It comes out to be 1 plus square root x multiplied by the derivative of 1 plus square root x, and it is 0 plus 1 by 2 square root x multiplied by 1, which needs not to be written. Similarly, next one becomes 1 divided by 1 minus square root x times minus 1 by 2 square root x. You have to take the derivative of 1 minus square root x, and it is equivalent to this one. It could also be simplified like 1 by 2 square root x multiplied by 1 plus square root x plus, because here negative and negative cancel out each other and become plus, 1 divided by 2 square root x times 1 minus square root x. Next you can take out 1 by 2 square root x as common between the denominators, and it comes out to be equal to 1 plus square root x plus 1 divided by 1 minus square root x. Next you can further simplify the function written in the functions written in the braces, and these are and it comes out to be equal to 1 plus square root x 1 minus square root x. Collect them, you might get 1 minus square root x multiplied by 1, which needs not to be written, 1 plus square root x multiplied by 1, which needs not to be written here, plus square root and negative square root cancel each other. You get 2 divided by, you can apply the formula a plus b multiplied by a minus b equal to a square minus b square here. So a is 1, 1 square is 1, minus b is square root x square is x. These two can be cancelled with this 2, and you might get 1 divided by square root x times 1 minus x, and this may be the answer of your question. Yup, it is. Next is the question number 25, which seems to be quite a bit, just a touch bit important. Question number 25 is e raised to the power ax, and this one is multiplied by cos of, the angle of cos is b arc sine b arc tan x, which is simply tan inverse x. So b times arc tan x is the angle of cosine function here, and this is equal to f of x, which has to be written at the left hand side because I forgot to write it, therefore I wrote it on the right hand side. Next you have to apply the derivative, because there is no space to simplify this function, so we will directly take the derivative on the both of the sides. F dash x, you have to apply the product rule. The derivative of e raised to the power x is e raised to the power x times the derivative of the power. You must be familiar to the derivatives of exponential functions, so if you know them, you can directly write it. The derivative of e raised to the power ax is a times e raised to the power ax. The derivative of the first function multiplied by the second function has to be written as itself, because we are using the product rule of the derivatives, plus the first function has to be written as itself, and you may have to focus on this step. The derivative of the cosine function, we have to take the derivative of this function cos b tan inverse x. Derivative of the cosine function is negative sine sine of the angle, and the angle is b tan inverse x, and you have to multiply this quantity with the derivative of the angle, d by dx of b times tan inverse x. Further simplify it, you might get e raised to the power x. First expression has to be written as itself. Next is plus and minus. When they get multiplied, you get minus e raised to the power ax sine of b times tan inverse x, and the derivative of b tan inverse x, because b is a constant, therefore we cannot take the derivative on it. We have to take the derivative of tan inverse x, and it is 1 divided by 1 plus x square. You must be familiar to the derivatives of trigonometric and inverse trigonometric functions, hyperbolic, inverse hyperbolic functions that are given in the theory of your book in the section 2.2. Times the derivative of the angle, that is x, it is 1. This is simply is equal to a times e raised to the power x cos of b tan inverse x minus e raised to the power x, and b could be written in the first, yes, b, and next one becomes sine b tan inverse x, and the whole of it is divided by 1 plus x square. I think that this is the answer of your question. Actually, you have to simplify it further. In the first expression and in the second expression, e raised to the power 1 by x is could be taken as a common. So you have to take it as a common, and you might get e raised to the power ax and here you get a cos b tan inverse x, and in the next you get b sine b tan inverse x, and the whole of it is not whole, the whole of the second expression is divided by 1 plus x squared. Simplify it further. Have to take the LCM, e raised to the power ax. Simplify it, you get a multiplied by 1 plus x square cos b tan inverse x minus b sine of b tan inverse x, whole thing is divided by 1 plus x square, because you can write this 1 plus x square here. So instead of writing these all of the quantities again and again, I may just write this 1 divide by 1 plus x square here under e raised to the power x, and this is the answer of your question. Next you have to solve out the question number 26, and it is quite important question. Question number 26, and it is f of x is equal to 1 divided by square root b square minus a square multiplied by natural log of square root b plus a plus square root b minus a tan x by 2 divide by square root b plus a minus square root b minus a tan x by 2. Now we will seek for the solution of this simple question. Before differentiating, you can simplify it by making use of rules of logarithm. So by applying the rules of logarithm, you get ln square root b plus a plus square root b minus a tan x by 2. Division is replaced with negative and natural log is distributed. You get this quantity. Next you will apply the derivative on the both of the sides. So f dash of x or f prime of x is equal to, since this quantity is a constant, therefore the derivative needs not to be applied here, so it will stay out of the case and the derivative is implied inside the parenthesis. You have to take the derivative of the first expression, and its derivative is, you have to apply the rules of natural log. 1 divided by square root b plus a plus square root b minus a tan x by 2 multiplied the derivative of this quantity, because you are applying the rule of natural logs. The derivative of this quantity could be written at the top. The derivative of the first expression is 0 because square root b plus a is a constant, and the derivative of the second one is again b minus a is constant, therefore derivative is not applied on this constant, and the derivative of tan x by 2 is secant square x by 2 and then multiplied by the derivative of x by 2, that is 1 by 2, and I will simply write it just below square root b minus a. Similarly, you have to apply the derivative on the second expression, that is minus ln and this one, and it is minus 1 divided by square root b plus a. You have to do the same thing here, minus square root b minus a tan x by 2 and the derivative of denominator has to be written at the top in the same way as we did previously in the previous expression, and we would get square root b minus a divided by 2, and here it is minus, therefore you would get minus secant square x by 2 multiplied by 1 by 2, that is written already here. This minus sign and this minus sign become plus, therefore we simply write here the sign of plus. Inside the square brackets, the numerator is the same in both of the expressions, therefore it can be taken as common, and we will take it out of the brackets as being taken common. Secant square x by 2 and the whole is divided by square root b square minus a square. What is left inside, it is 1 divided by square root b plus a plus square root b minus a tan x by 2 and plus 1 divided by square root b plus a minus square root b minus a tan x by 2. Simplify this term. 2 should be written below, and simplify this one. You have to apply the formula a square minus b square, that is equal to a plus b, and separate the square root sign. B minus a multiplied by square root b plus a, and the numerator is as it is, secant square x by 2. Just we have taken 2 below. Simplify this one. What is the LCM? Note that this quantity and this quantity is same. Similarly, this quantity and this quantity is same. So if it is a, then it is a. If it is b, then it is b. Then we have a plus b and a minus b, and the LCM is simply the product of these two, that is a square minus b square. So a square, it means that b plus a square, square root b plus a whole square, and it is simply b plus a. So a square minus b square, and the b square is by b minus a whole multiplied by tan square x by 2. What is left at the top? We are left with square root b plus a minus square root b minus a tan x by 2. That means that we are using the LCM method here, plus square root b plus a plus square root b minus a tan x by 2. It is obvious that this quantity gets cancelled with this one, and this quantity and this quantity is same. Therefore we get here 2 times square root b plus a, and the denominator remains as it is, b plus a minus b minus a tan square x by 2. Here square root b minus a and square root b minus a are simply cancelled, and we have secant square x by 2 whole divided by 2 square root b plus a. 2 square root b plus a and 2 square root b plus a, they simply cancel each other, and we have in the next step this expression. And here it is written tan square x by 2, which could also be written as sin square x by 2 plus divided by cos square x by 2 divide by cos square x by 2. And in the next step you have to again apply the LCM method, and by doing that you would get, okay, let me write it there in the next step, because it would be better to write it in the next step. Secant square x by 2 multiplied by 1 divided by, apply the LCM method here, you get a plus b or b plus a cos square x by 2 minus b minus a sine square x by 2 and whole is divided by cos square x by 2 . This cos square could be written at the top, and when it goes at the top it becomes cos square x by 2 multiplies secant square x by 2, and secant square x by 2, because it is the reciprocal of cos square x by 2, therefore it simply cancels this one, and we are left with only 1 divided by a plus b cos square x by 2 minus b minus a sine square x by 2. Let me check the answer. This question number 26. You have to further simplify it. So we would have further simplify this one. Apply the distributive law. A cos square x by 2 plus b cos square x by 2. Similarly, apply the distributive law here. Minus b times a sine square x by 2 and minus plus a times sine square x by 2. Collect the quantities with a coefficient, taking a common between those two quantities, we get cos square x by 2 plus sine square x by 2, and collect the quantities with the coefficient b. It is cos square x by 2 minus sine square x by 2. Next, everyone knows that sine square theta plus cos square theta is equal to 1. Therefore, cos square x by 2 plus sine square x by 2, it is also 1, plus b, and everyone also knows that cos square x minus sine square x, it is equal to cos 2x. So therefore, when you will apply this formula here, you would get it is cos 2 and angle is here x by 2. 1 divided by a plus cos x2, and cancelled with 2, we are left with cos x, and it is the answer of your question. Now we'll move to the next question. It is question number 28, and this question is also important from paper point of view. Question number 27 is very simple. I think that it can be done by yourself. Okay, I will solve it in this question number 27. It is f of x is equal to a raised to the power x e raised to the power x sine hyperbolic x. Sine hyperbolic x, take the derivative, apply the product rule. Derivative of the first, that is 1, needs not to be written. Multiply second function multiplied by third function, plus derivative of first function as it is, derivative of the second one, and it is a raised to the power x ln a multiplied by third function as it is. Note that the derivative of a raised to the power x is ax ln a, and then in the final, first function as it is, second function as it is, derivative of the third function cos hyperbolic x. What is the common? The common is sine hyperbolic x, no sorry, a raised to the power x, and the rest would be the answer. So it can be written by yourself. We move to, and this was just two-step question. Let we move to the next question, and it is very important from viewpoint of the paper. It is question number 28. F of x is equal to minus cos x divided by 2 times sine square x plus 1 by 2 ln tan x by 2. You have to differentiate both of the sides with respect to x. So f dash x, in the first quantity you have to apply the quotient rule. The derivative of the top one is minus sine x and the second, or the denominator, remains as it is. When it multiplies with sine x, you get 2 sine cube x minus numerator as it is, the derivative of the denominator, and it is 2 times sine x. You have to apply the power rule, multiply the derivative of base, that is cos x, divide by 4 sine 4x, and instead of writing cos x and 2 here, you simply write 2 cos square x. 2 cos square x multiplied by sine x. And you can further simplify it. You can take sine x common, and when you will take sine x common, here it would be sine square x, and the sine x that has been taken common, it makes this sine cube x. so that step would have to be done by yourself. Derivative of the next thing is 1 by 2 has to be taken outside. Apply the derivative here. 1 divided by 10x by 2 multiplied by secant square x by 2 multiplied by 1 by 2. Take minus 2 common from the first expression and you would get sine square x plus I think there happens to be a mistake, and the mistake is that here it comes 4. You may check it out. It comes here 4 because 2 that I wrote here, it was the 2 taken from the power rule, and the denominator there was also 2 there in the denominator, and when it gets multiplied with the first 2 it becomes 4 definitely. So sorry for that. You have to take 2 common and you would get cos square x plus sine square x plus 2 cos square x divided by 4 sine cube x. So 4 is cancelled with the top 2. The 2 that was taken common from here, minus 2 actually, and it becomes plus 2, and it cancels with the 4 in the denominator and it makes it 2, and 2 times sine cube x. The next thing is plus this 1 by 2 when multiplied with 1 by 2 it becomes 1 by 4 secant square x by 2 divided by 10x by 2 could be written as sin x by 2 divided by cos x by 2. Sin x by 2 divided by cos x by 2. You have to further simplify it. Sin square x plus 2 cos square x divided by 2 sin square x. This cos x by 2 could be taken at the top and it cancels the secant square x by 2, and you're left with only secant x by sorry, it could not be cancelled. Yes, it could be cancelled because here it was secant square x by 2. So this cos x by 2 goes at the top and you would get a single secant x by 2, and in the denominator it is sin x by 2. You can take this secant x by 2 again back down here, and since secant x by 2 is the reciprocal of cos x by 2, therefore it could be written here cos x by 2 multiplied by sin x by 2. And because I'm using the formula, double angle identity I will write here too, and I will supply the other two here with this denominator. Next I'm using is sine 2x is equal to 2 sine x cos x. So when you replace x with x by 2, then you will get 2 sine x by 2 cos x by 2 equal to sine x. So therefore this quantity becomes simply sine x. Sine square x by 2, the first expression will remain as it is, divided by 2 sine square x plus 1 by 2 sine x. And this is not sine square x, it is actually sine cube x. Let me confirm it from the previous steps. Yes, it is sine cube x and sine cube x, yes. Next you have to take again the LCM, and the LCM is obviously 2 sine cube x, and here you would get 1, yes, 1 multiplied by sine square x plus 2 cos x multiplied by, when this 2 cancels this one, and you would get sine square x. Here we have just applied the LCM method. Sine square x plus sine square x, 2 sine square x, and here it is not cos x, it is actually cos square x. So another mistake is here, it is cos square x, this is cos square x, and sorry for this mistake. Two sine square x plus 2 cos square x divide by 2 sine cube x. Take 2 common and you're left with 2 sine square x plus cos square x, and in the denominator there is 2 sine cube x this 2 and this 2 is cancelled. Numerator is sine square x plus cos square x, that is 1, and the denominator is sine cube x, that is cosecant cube x is your answer. Let me confirm it. Yes, it is cosecant cube x. The final question would be question number 30. Question number 29 is very simple, and you have to be familiar with the derivative of a secant inverse function, and you may be able to solve it. We will solve the last question, that is the question number 30, and this is very simple. I will not solve it very completely. F of x is equal to 1 plus 1 divided by x whole raised to the power x square, variable in the power of variable, so therefore you have to apply the natural log. Plus 1 divided by x whole raised to the power x square this x square becomes in the start of the natural log. Yes, it comes there, and you have just ln f of x. Next, you have to differentiate both of the sides by making use of power rule, and here you may have to apply the natural log rule. 1 divided by f of x times f dash of x, product rule here, plus first function as it is, the derivative of the second one, derivative of 1 divided by 1 plus 1 divided by x multiplied the derivative of this 1 plus 1 by x, it is negative 1 by x square. You must be familiar with the power rule, etc. This x square simply cancels with this one, and you have just 2x ln of 1 plus 1 divided by x minus 1 divided by, take LCM method, apply LCM method here, x plus 1 divided by x, and that divided by x could be taken at the top, and you have 1 divided by f of x times f prime of x equal to this quantity. In the final step, you just have to take f of x at the right hand side and replace f of x by its equivalent value, that is your question, 1 plus 1 by x whole raised to the power x square, and you would get the answer. Thanks for watching.